I will be discussing my research, a preliminary comparison of fuel economy estimates from driving cycles developed using road load energy-based and microtrip method. I would like to acknowledge my co-authors, Dr. Edwin Quiroz, Dr. Gerald Joe Denoga, Engineer Robert James Lamotan, and Engineer Peter Vasquez. So what is a driving cycle? A driving cycle is a series of data points representing the speed of a vehicle versus time. A drive cycle is a compressed speed versus time trace that is representative of a driving pattern in a particular environment. It aims to mimic real-world driving behavior using limited duration activities with the primary purpose of simulating exhaust gas emissions and fuel economy of vehicles. One of the purpose of driving cycle is to compress data being gathered. As we can see in the figure, an actual driving time or data points of 55,000 plus are being compressed into less than 2,000 seconds of driving time. As in the presentation, 55,000 plus seconds of driving time are compressed into a 540, 1,400 second drive cycle, and 2,000 seconds of driving cycle. The most common method in generating drive cycle is the microtrip method. Microtrip-based cycle construction can be defined as driving activity between adjacent stops, including leading idle period. In this method, the real data is divided into microtrips and assigned into different bins according to average speed. The cycle is constructed using microtrips such that the target parameters are met. For selecting microtrips for the cycle, there are two main methods, namely the random selection and best incremental method. In this research, I've used the random selection method. So the objective of the research is to generate a drive cycle using energy road load criterion for a public utility jeepney with an average of the varying load with the consideration of the average occupancy. Analyze the different parameters measured from the conventional drive cycle development methodology, such as average velocity, percent idle, average acceleration, and average deceleration, with the same parameter obtained from the conservation of road load energy criterion for a public utility jeepney. Compare the actual fuel economy and the fuel economy of the generated cycle as tested on the chassis dynamometer using conservation of energy road load criterion and microtrip method on the public utility vehicles. The methodology is divided into four phases: data acquisition, data processing, drive cycle generation, and validation. A route of a public utility jeepney shall be identified. So in this route, manual tallying of occupancies, boarding, and alighting, and speed time profile of the subject vehicle was recorded for the development of this cycle. So the route plies through the Pitan to Baclaran via Mabini Highway and vice versa. So with an approximate distance of 26 kilometers and would usually take 2 hours per round trip. The developed drive cycles shall be used in the simulation of driving in the chassis dynamometer at the Vehicle Research and Testing Laboratory to measure fuel consumption. So initially, the data processing. So initially, the date time differential distance and differential time was extracted from the data logger. So the figure shows sample of the data. Velocity will be computed with extracted differential distance and differential time, then the computed velocity will be then rounded off, and the accelerations were being computed. Computation for average passenger loading will then be needed, and the easiest way to measure the passenger kilometer is to conduct a sample boarding and lighting survey. So for this instance, with a jeepney with random stop, it is adequate to divide those route length by the time of the drive cycle to calculate the average stop distance. So place kilometers are simple to measure, being the kilometers operated by all the jeepney on a route times the average capacity of the PUJ, or the public utility jeepney on the route. Then lastly, the construction of the velocity acceleration probability matrix. So there are two drive cycle development that was used in this research. So the RLE, or the road load energy criterion method, which was developed by Dr. Gerald Joe Denoga of the Mechanical Engineering Department of UP Diliman, and the Microtrip method, which was discussed earlier. So invalidating the drive cycle, the generated drive cycle was tested on a chassis dynamometer. Fuel consumption of the drive cycle generated was measured using the same instrument used in the road data gathering. Then the results were compared to the actual road fuel consumption. Also, other assessment measures such as the average velocity, average acceleration, average deceleration, and percent idle time was compared to on-road values. Lastly, the drive cycle generated using the microchip method was tested on the chassis dynamometer using the first four procedures mentioned. So selecting drive cycles using energy road load criterions are generated by using MATLAB, and drive cycle selected using microchip method is generated using the Visual Basic in Excel. So in order to analyze the performance, the drive cycles generated using conservation of energy road load criterion and microchip method is tested on a chassis dynamometer, and results are then compared. So actual road data here is 18 round trips with a total of 55,000 plus seconds that have been combined so that the tallying can be done without difficulty. So first, the generated driving cycle using conservation of energy road load method in the study had a lower minimum and maximum acceleration and lower percentage idle compared with the drive cycle generated using microchip method. So in this case, a lower maximum acceleration and lower percentage idle corresponded to lower fuel consumption. Also, a fuel consumption using microchip method is larger compared to the percentage of fuel consumption using conservation of energy road load criterion on the jeepney. So the highest fuel consumption values were all realized with the microchip method, where it was attributed to the load input to the chassis dynamometer. So lastly, in the process of using the conservation of energy road load method, the method is using likelihood estimation. So in addition to the speed factor considered, acceleration factors and load factors are taken into account, which make the drive cycle more detailed. So the results show that the drive cycles generated using conservation of road load energy criterion are more scientific, reasonable, and drivable, and the development based on it is more representative compared with the microchip method. So for the recommendation, so use of multiple route plying through major route in the Philippines, develop drive cycles using conservation of road load energy method on different vehicles, survey for shifting gears, comparing conservation of road load with other methods, and the inclusion of random sampling for emissions. So that's it for my presentation. Thank you.